Hello everyone, welcome to MEP Booster. So in this lecture, we are going to discuss combined sprinkler and standpipe system. After the end of this lecture, you would be able to understand what is combined system. Then we'll discuss about the components of combined system. After that, the combined system design requirement. Okay, so let's start. So here first of all, we'll discuss what is actually combined system. See, a combined system means what? A combined sprinkler and standpipe system integrates both fire sprinkler and standpipes into a single piping network. Okay, you can see in this image. Here it is written, a combined sprinkler and standpipe system integrates both fire sprinkler and standpipes into a single piping network. Okay, if you see here in this image, here we have a both pipe, fire sprinklers, pipes is also going in each and every floor. Even see we have placed the standpipe. Okay. So it provides automatic fire suppression, sprinkler and manual firefighting capabilities from a common water supply and pump system. That is called as a combined system. Okay. Is it clear? So combined system uses the same piping and pump for both sprinkler head and fire hose connection, means the standpipe. And it reduces the cost and simplifies maintenance. Okay. So it is common in high-rise building. Now here we'll see the components of combined system. So we have a lots of component. Here few of them we'll discuss. See, in that the first component is showing water supply. You know that we have a water supply source, municipal supply, fire reservoir or overhead tank. Okay. So based on your total demand of a sprinkler and a standpipe system, we have to do the sizing of reservoir, overhead tank. Okay. Second is the fire pump set. So here we have a different, like we have a main pump, okay, which supply water to both system. Main pump means electric pump. Then we have a jockey pump which maintain pressure and prevent false alarm. Then we are using the diesel pump also, backup power for fire emergencies. So these all I have discussed in detail. Okay. Then we have a piping network, common riser for both sprinkler and standpipe. Normally the material which we are using for piping is steel, black or galvanized or CPVC for small building. Okay. Then the next component is standpipe system. So here we have a hose connection, typically 2.5 inch outlet with 1.5 inch reducer for fire department use. Okay. So we have a 3 types of standpipe system. Okay. As I discussed earlier, class first, second or third. So based on user type and hose size. Okay, in class first standpipe system, normally we have a 2.5 inch hose connection. And if you go for class second, so here we have a complete hose station, 1 or 1.5 inch hose station. And class third is the combined of class first, and means here in the class third standpipe system we have both. It is the combined feature of class first and class second. Means here we have a 2.5 inch hose connection, even 1 or 1.5 inch hose station. Clear? Then the next component, it is given here, sprinkler head. Okay. So as you know that sprinkler head automatically discharge water when heat trigger the glass bulb or fusible link. Okay. We have a different types of sprinkler head. As I discussed earlier, pendant, upright, side wall, okay, and some special type of sprinkler head is also available. Then valves and accessories. Okay, so different types of valve we are using now. Alarm valve, which activate alarm when water flows. Then we have a pressure relief valve, which prevent excess pressure buildup. Flow switch also we are using, which send a signal to the fire alarm control panel. Then control valve normally isolate section for maintenance. Okay, so different types of valves and accessories are there. And then finally, we have a fire department connection. It is the external connection point. Okay. The system designed for the fire requirement to pump water directly into the system. 13 and clear? NFPA so these are the 40 main component of a combined system. So in that, if you see, the first point is given water flow requirement. See, for sprinkler, based on area hazard classification, means you know that in case of light hazard occupancy, 0.1 GPM per square feet. Over the most remote area is 1500 square feet. This is the water flow requirement for light hazard. If it is a ordinary hazard, so 0.15 GPM per square feet. Over the most remote of 1500 square feet. Correct? Same way, you can go for the extra hazard. Okay. It is given here. For light hazard 0.1 and for ordinary 0.15 GPM per square feet. And if it is a standpipe, so the minimum of 500 GPM for the first standpipe plus 250 GPM for each additional standpipe. The maximum flow should be 1250 GPM, not more than that. Okay. Now if you see the pressure requirement, so for sprinkler, the minimum we need 7 psi at the most remote sprinkler. Minimum pressure, how much? 7 psi at the most remote sprinkler head. See, most remote sprinkler head means the sprinkler which is farthest from the pump, okay, from the water supply source or from the pump, okay, that sprinkler is called as a most remote sprinkler head. Suppose, let's say, if your pump is in the ground floor level and you have a 6th floor building, so in the 6th floor, the sprinkler available, na? So that sprinkler, farthest sprinkler, is called as the most remote sprinkler head. Next, standpipe. So here in a standpipe, the pressure, minimum residual pressure of 100 psi at the highest outlet for class first is needed. Okay. Residual pressure means the pressure acting at a point in a system when flow being delivered. Okay, so 100 psi minimum. So based on the classes of a standpipe, if it is a class first standpipe, so minimum 100, maximum 175 psi. If it is a class second standpipe, so minimum 65 psi, maximum 100. For combined system, both same, 100 psi minimum, maximum 175. Okay, so remember this point. Now next thing is pipe sizing. So remember the riser pipe, when you are sizing the riser pipe for combined system, so it should be minimum 6 inches diameter. Okay. Pipe size is totally depends on the sprinkler pipe size, standpipe, that will discuss already in hydraulic calculation. Will show you how to find out the sprinkler pipe size, standpipe pipe size, and in the previous lecture also I have discussed. Okay. Here the requirement is given that for the combined system, riser means the vertical pipe which is running now, which we are running throughout the building. So the minimum diameter of that pipe should be 6 inch, correct? And for branch line, size according to sprinkler demand. Clear? So these are the system designed requirement. Now we'll see the installation detail. So here it is given the riser location. Normally the riser location is centrally located for easy vertical distribution. Zoning. Here we need to divide the floor into zone based on height, typically every 30 meter. Clear? And then isolation valve installed on each floor to isolate section during maintenance. Then properly mark all control valve and hose cabinet, so signage is needed. Then see, as per NFPA 13 and NFPA 14 standard, we have to use the pipe hanger and support. Okay. So these are the installation detail is given here. Now here some advantages, means the benefits of combined system is given. So we have a lots of benefits. Few of them we'll discuss here. So in that, the first is given what? Cost effective. So remember, the single pump and riser for both sprinkler and standpipes. Okay, here we are using single pump only, na, for both sprinkler and standpipe. So it is cost effective. Second is space saving, because why? It reduces, this system, combined system, reduces the number of pipes and installation area. So the space saving also. And then reliable means redundancy from shared water supply and pumping system. Okay, clear? Now we'll see the disadvantage of combined system. The first one is what? Complex design. Yes, because you know that this combined system required detailed hydraulic calculation. So it is a complex design. This is the first disadvantage. Second, single point of failure. So here a pump failure affect both system. Okay, so this is the another disadvantage. And then high initial cost. Yes, because you know that more expensive, it is more expensive than standalone system. So initial cost is high. Clear? So these are the disadvantage of combined system. So now here you can see in NFPA 14 2007 edition chapter 7, here the design requirement is given for combined system. Okay, so here in this slide the image is taken from the each and every point which is written is taken from the NFPA 14, okay, 2007 edition and chapter 7. So design is specifically discussion combined system. Okay, so here try to understand the combined system as I told you in starting. Okay, all of you know that combined system is a fire protection system where the automatic sprinkler system and standpipe system share the same water supply. Correct? So instead of separate piping for sprinkler and standpipe, the system is designed to serve both from a common water source. Okay, that system is called as a combined system. Now here the important thing, how you can find out the flow for combined system, how much GPM. This is the important factor. So here the point is written. The first point, for a building protected throughout by an approved automatic sprinkler system, the system demand established by section 7.7 and 7.10.1 also shall be permitted to serve the sprinkler system. Okay, so it means what? Suppose if a building is fully protected with an approved automatic sprinkler system, then the water supply must be designed to meet the greater of the following. Means the greater of the system demand for sprinkler as per NFPA 13, okay, and the hose stream allowance for the standpipe system. That is written here. You can see where the sprinkler system water supply requirement including the hose stream allowance as determined in accordance with the NFPA 13 standard for the installation of a sprinkler system exceed the system demand. So here we need to calculate. First we need to do the hydraulic calculation for both. Okay, that I will explain you. So whichever is greater, that we have to consider. It means what? See, this means that if the hose stream allowance water needed for fire hoses is greater than the sprinkler demand, then the higher value must be used in the design. Okay, remember this thing. This is the exact meaning of this point. Now next point is separate sprinkler demand shall not be required here. It means if the system already account for the higher water demand either from the standpipe or sprinkler, no separate sprinkler demand need to be added here. Okay, and the most important point which is given here, for a combined system in a building equipped with partial automatic sprinkler protection. First you need try to understand what is actually partial automatic sprinkler. See, partial sprinkler protection means that only certain area of the building are covered by sprinkler rather than having a full sprinkler system throughout the entire building. Okay, clear? So here in this point it is described that for a combined system in a building equipped with, suppose in any floor you have placed you have installed the automatic sprinkler system, that is called as a partial. So with partial automatic sprinkler water demand, the flow rate required by this table taken from the NFPA shall be increased by an amount equal to which outlined hose stream allowance demand and water supply duration requirement for light hazard hydraulically calculated or by 500 GPM. So let's see ordinary hazard occupancy and try to understand the table component. Okay, so first if you see the table, so if a building has a partial automatic sprinkler parameters, Not fully sprinkler protect. Parameter is the occupancy only in any one of the floor you have. So this refers to the hazard. So the floor rate required of the by this light hazard section, which is given here 7.10.1 hazard. Already standpipe demand must be increased by what is actually which building will comes under light hazard, which building will comes under ordinary hazard. 150 GPM. Already we have discussed for light hazard occupancy. Next thing 500 GPM for ordinary hazard inside occupancy. Whichever is less rate in GPM. Okay, should be considered in the calculation. So the possible required flow rate for internal hose station within the building is 0, 50 or 100 GPM. Meaning depending on the designing need. And an internal hose allowance may or may not be sprinkler building. Okay, then we have a total use the higher of a sprinkler demand or hose stream. It is the sum of inside and outside sprinkler building hose increase the required flow rate by the minimum water based on hazard for firefighting. If you see in case of light hazard 100 GPM, 500 for ordinary hazard 250 for extra. I will take one example 500 GPM. Correct. Then here the duration is given. This is the minimum time for which the required water flow must be maintained. For light hazard 30 minutes, for ordinary 60 to 90 minutes, and for extra 90 to 120 minutes. Okay. So you need to remember this thing. Okay. The first thing which you need to remember is what? The water demand increases with hazard level. If you see higher risk area like extra hazard need more water for longer duration, you can see here. Okay, and depending on the building fire protection strategy, an inside hose allowance might be set as 0, 50 or 100 GPM. Okay, so now let's see the example which we have discussed. So here you can see one example is shown for light hazard occupancy. Here it is written light hazard typically throughout building at all floor. Okay, so the diagram illustrate the flow rate distribution for a combined sprinkler and standpipe system. So let us analyze each part in detail. So here what happened? See, as I told you, the combined system integrate both sprinkler for automatic fire suppression, standpipe for manual fire suppression via hoses. So if you see here, we have a sprinkler, even the standpipe means the hose connection is also given. Okay, so here if you see what is given here, the standpipe, as you know that all of you know that for the most remote standpipe what is the flow rate? See here it is given clearly. If it is a class first standpipe system, normally in this the image which I have shown is normally a class first stand. So here we have a 2.5 inch hose connection. Even the minimum their requirement is given for class first standpipe system. Minimum residual pressure 100, maximum 175. And see the important thing which I want to show you is at this point. The minimum flow rate for the hydraulically most remote standpipe shall be how much? 500 GPM. Means hydraulically standpipe system means most remote standpipe system means the standpipe which is farthest from this pump. So if you see in this image, we have two standpipe, one here, but the farthest one is this B. So here the minimum flow rate for the hydraulically most remote standpipe shall be 500, and if you have any additional standpipe system, so shall be 250 per standpipe. But here one condition is given for additional standpipe 250. But condition is what? For building not exceeding 80,000 square feet floor area. If building exceeding 80,000 square feet floor area, so the minimum flow rate for additional standpipe shall be 500. Okay, for the second standpipe, and for the remaining 250. Correct? Remember. So let's say here we are assuming in our case the example which I have shown. Suppose our building area is less than 80,000 square feet floor area. Correct? So the minimum flow rate for additional standpipe, sorry, 250, and the most remote standpipe 500. So same it is written. So first thing, as we have seen, this is a 2.5 inch hose connection. So for the most remote standpipe, how much? 500 GPM, correct? And if it is a additional, so 250. So here I have added 500 GPM for most remote riser, 250 for additional riser. So the total demand we have got for this is the standpipe flow rate, okay, 750 GPM total demand, okay, 500 GPM. This is the required flow rate for the most hydraulically remote standpipe, okay, and 250 GPM. If the system has more than one standpipe, additional riser each required 250 GPM, as I told you, if your floor area is less than 80,000 square feet. So total we have got 750 GPM. The sum of the standpipe demand, okay, is 750 GPM, correct? So here we have calculated the standpipe flow rate, total 750. Now you need to calculate the sprinkler flow rate. So if you see, the sprinkler flow rate is given, as I discussed earlier, that in case of light hazard, 150 GPM sprinkler is given, okay, of 50 GPM inside hose stream allowance, additional requirement per flow, okay. So if you see here, the total sprinkler flow rate is 200 GPM are not required to be added to standpipe flow rate. This means that the flow demand for sprinkler does not need to be summed with the standpipe demand. Here you have to see, and one more thing you can do. In this case, normally the sprinkler flow rate is less than the standpipe flow rate. So it means always we have to consider the larger flow rate, so which is 500, and plus this additional. So total we have got 750 GPM. Clear this thing? In this way we need to calculate the flow rate for the combined system, okay, whichever is greater that you have to consider. So you can do like this also, separate, just do the hydraulic calculation separately for sprinkler system or for standpipe. So now you have to see the flow value, whichever is larger that we have to consider, okay. No need to sum with the flow demand for sprinkler does not need to be summed with the standpipe demand, okay, whichever is greater that we have to consider. So is it clear? Now here you can see this 750 GPM, this is our total demand. As per that we have to do the selection. Clear? Second, here we have an ordinary hazard. You can see in it is given clearly here, it is written. So suppose if your building will comes under ordinary hazard, so on that time, so see this diagram represent the flow rate distribution for a combined system and sprinkler designed for ordinary hazard occupancy, okay. So in this case, if you remember, I have discussed here, if you see, suppose we have calculated for combined flow rate, our main target is to calculate the combined flow rate. So first, as I told you, first you have to see in this standpipe, how to calculate this standpipe flow rate. Simple. For the most remote standpipe system, yes, the flow should be 500 GPM, all of you know, for the most remote standpipe system, and for additional 250. So here if you see, for the most remote riser, the flow for standpipe is 500 GPM. Now let's say if you have calculated the flow for sprinkler and you have got 500 GPM for sprinkler also, even 100 GPM sprinkler inside hose stream allowance, okay. So here if you see, we have a 600 sprinkler flow rate is coming 600 GPM, exceed standpipe flow rate 500 GPM, okay. So the size of riser we have to do, means the flow demand, riser pipe size you have to go for this 600 GPM, okay, remember. So this 600 GPM, this is the required flow rate for the most remote hydraulically sprinkler, okay. Clear this thing? So 600 GPM means sprinkler flow rate is coming more than standpipe, so it means we need to consider the sprinkler flow rate 600, and for additional standpipe 250, you know that. So 600 plus 250, 850 GPM, this is our combined flow rate demand. In this way you need to calculate. It is very simple, okay. Now let's say if you have a partial sprinkler, if you see in this image, so you will understood. As I told you, partial sprinkler protection means that only certain area of the building are covered by sprinkler. In this image, if you see, only in this floor we have a sprinkler, rather than having a full sprinkler system throughout the entire building, okay. So in a given diagram, see 150 GPM is allocated for partial sprinkler at this floor number 5, let's say, okay, which suggests that what, see, because I have discussed already the points, if you remember, okay, that point 150 GPM for partial sprinkler, okay. So here in the given diagram, as I told you, 150 GPM is allocated for partial sprinkler at floor 5, which suggests that sprinkler are installed only in a specific high-rise area such as storage room, electrical room or corridor. The rest of the floor may rely on the standpipe system for manual firefighting, okay. So this is common in light hazard occupancy where the fire load is low and full sprinkler coverage may not be required by code, okay. So here, so 150 GPM we have, see how to calculate the combined flow rate. It is very simple. 150 GPM for partial sprinkler we have considered as per NFPA. Then 500 GPM, because you know that when you calculate here, so for the most remote standpipe 500 GPM flow and for additional 250. So when you add, see 900 GPM total demand will get. Okay, simply in this way we need to calculate. You can see here the requirement is given clearly, okay. See, for partial automatic sprinkler protection, the flow rate shall be increased by an amount equal to the hydraulically calculated sprinkler demand or 150 GPM for light hazard. So you can add additional 150, or otherwise, see, you can add 150 GPM, otherwise calculate, do the hydraulic calculation separate for that sprinkler. Whatever flow you are getting, that you need to consider. This is for light hazard. For ordinary hazard, 500. Okay. So in this way, you will get the total demand for combined system. Hope all of you understood about this. Okay. Clear? So now the topics which we have covered here. First, we have discussed what is combined system, then their component of combined system. After that, I have shown you the combined system design requirement, advantage and disadvantage of combined system. Then finally we have discussed the combined system flow rate calculation. Hope all of you enjoy this session. See you in next one.